Hi guys, this is section 5.2b. Now we're going to use factoring to solve. And so we're looking off page 258 and we're looking at example 5. On example 5 they give us x squared plus 3x minus 18 equals 0. And this equals 0 is the way that I know that they want me to solve it. They don't just want me to simplify it by factoring. They want me to find what x is as well. Before you start factoring, it always has to be set equal to 0. It always has to be set equal to 0, okay? All right, so, sorry, I thought I was going to sneeze. Okay, so ignore this for right now and take care of your first, or your factoring part. So you have 3 terms. The first question is, can you take anything out? No, you can't. Are the first and the third perfect squares? No, they are not. So we need to proceed with general factoring. X and X is going to go in my first spot. Factors of 18, 1 and 18, 2 and 9, 3 and 6. So if I pick one of those sets that will add or subtract to give me 3, I'm going to try 3 and 6. So this would give me 3x, and this would give me 6x. If I made this negative and this positive, negative 3 plus 6 is positive 3. That means it works like that. If I do my double check, negative 3 times 6 gives me negative 18. So there's my factoring right there. X minus 3, x plus 6 equals 0. Now we have to solve it. This part's easy. I take each set and set them equal to 0. So I have x minus 3 equal to 0, and I have x plus 6 equal to 0. Now I just need to get x by itself. X equals 3. X equals negative 6. There's my 2 solutions. Okay, so we'll say that again. Make sure it's equal to 0. Factor the one side, then take their sets, set them equal to 0, and get x by itself. So let's try that on part B. Part B says 2t squared minus 17t plus 45 equals 3t minus 5. And I know I have to solve to factor, and I know I have an equal sign here, so that tells me I have to solve. So the first thing, remember, we said on our last one is it has to be equal to 0 before I can start factoring. So I need to get everything on one side. So I'm going to subtract this guy over and add him. Subtract him over and add him to his like terms. So that gives me 2t squared minus 20t plus 50. Now that I have it equal to 0, now I can factor. Can you take anything out? Yes, I could take a 2 out. So I have t squared minus 10t plus 25. Are the first and the third perfect squares? Yes, they are. Their roots would be t and 5. And remember, together times 2, they're supposed to equal 10. T times 5 is 5t, times 2 is 10t. So yes, that works. So it's either an a minus b squared or an a plus b squared pattern. Since we have the minus plus, ours is the minus pattern. All right, now I'm going to take my sets and set them equal to 0. Notice, this doesn't look like a set, but he is. Whatever's out front, sets equal to 0. T minus 5 equals 0. Remember what this quantity squared means. That means that there's just 2 of these t minus 5s. Okay, I don't necessarily have to do this because isn't their solution going to be the same? They're exactly the same. I don't have to do that one. Okay, so let's start over here. 2 equals 0. Is there any variable involved here? No. And does 2 equal 0? No. So he doesn't have a solution. It doesn't mean that the whole thing doesn't have solutions. It just means that this part doesn't have one. How about this guy? Add 5 t equals 5. That's my only solution. Now remember, it would have been his solution too, but that's okay. We don't have to write it twice. It's actually called repeated, but you don't have to write it twice. Okay, so let's try this on number 69 and 77. Actually, I changed my mind. Let's do 71 and 77. So 71 gives me 81n squared minus 16 equals 0. Remember, that equals 0 piece is the way we know we are solving. To factor, it has to be set equal to 0. Ours does. We don't need to move anything around. We're ready to factor. 2 terms. Can I take anything out? No. Is it a difference of squares? Well, it's definitely a difference. Are these two square numbers? Yes, they are. 9n and 4. So that gives me the pattern. Remember, a plus b, a minus b, or in our case, 9n plus 4, 9n minus 4. Now I'm ready to take those sets and set them equal to 0. So to get n by itself here, I'm going to subtract 4. Divide by 9, sorry. So n equals negative 4/9. Now I'm going to do it to this side. Divide by 9. So n equals positive 4/9. And there's my two solutions. Okay, let's do that on 77. (77) gives me 2y squared minus 4y minus 8 equals negative y squared plus y. Okay, we know we have to solve because we have the equal sign, but we know it has to be set equal to 0. That means I need one side to be equal to 0. So let's move this guy over and this guy over. Notice I'm using inverse operations, so they cancel out. So then I have 3y squared negative 5y minus 8. 3 terms. Can I take anything out? No. Are the first and the third perfect squares? No. Proceed with general factoring. Factors of 3 are just 3 and 1, so we might as well go and throw him in. Factors of 8, though, are 1 and 8 and 2 and 4. All right, not one is really bigger than the other, so I'm going to go ahead and just put 1 and 8 in. This would give me 1y, and this gives me 24y. If I add them, that gives me 25. If I subtract, that gives me negative 23. I'm trying to get negative 5, so that's not going to work. Before I rule him out, let's switch his order. Let's make him 8 and 1. So now I have 8y and 3y. How could I get to negative 5? Well, I could if I made it a negative and a positive. Negative 8 plus 3 is negative 5. And if you double check that last term, negative 8 times 1 still gives me negative 8. So there's my factorization. Now take those sets and set them equal to 0. So now I have 3y equal to 8, y equal to 8/3, and y equal to negative 1. There's my solutions. Okay. All right, now the last piece of this, I let you guys take a little shortcut on. The last piece of this, I let you take a shortcut on. If you take a look at example 7, On page 259, it asks for zeros. Zeros are the same as solutions. They're the same as x-intercepts. They're the same as roots. They're all the same thing, okay? They can call them different names. All right, if it asks for zeros in this chapter, in the quadratic function chapter, I will let you use your calculator. So for instance, on example 7, it doesn't ask you to solve. It doesn't ask for solutions. It asks you to find the zeros. All right, and I said I'm going to let you use your calculator. So you're going to take your calculator and you're going to go to y equals, and you're going to type in your equation. So you have x. Notice this x key right here. I know some of you guys like to use that alpha x. Just use your variable key right here. So we have x squared. Let me clear mine out first, sorry. X squared minus x minus 6. Goodness gracious, sorry guys. Okay, you can go ahead and hit graph if you want. Now my window's kind of messy here because I was using it in the other class. So I'm going to go to window, and usually you want your mins to be -10, which mine were, and your maxes to be +10. So I've got a max of 225. I'm going to change that to +10. We know our graph should look like a parabola, guys, okay? So it should look like a U-shaped graph, or you've done something wrong. Now, you're going to go to, well, first off, let's just talk about what I just said, okay? Remember, solutions are the same as zeros. They're the same as x-intercepts, and they're same as roots. So if this question is asking me for zeros, and I'm looking at a graph, zeros are the same as x-intercepts. Where do I find x-intercepts? Where it crosses the x-axis. Now, I could maybe look at this graph and estimate it, or I could find it exactly by using our zero function. If you go to second trace, we want 0. Okay? I'll try to get a little closer so you guys can see. Okay? Now, if you can see this, and I know there's a glare, I'm sorry about that. I know there's a glare. It's asking for left bound, okay? Well, remember, there's 2 x-intercepts we're looking for. One is right here, and one is right here. You're going to have to do this separately. So when it says left bound, what it means is I want to be on the left side of this x-intercept. The left side would be over here or on the top of this graph. So I'm going to take my little cursor. I'm just using my left arrow key, and I'm going to get him on the left-hand side. And I'm going to hit enter. Now it asks for right bound. So now it wants me to be on the right-hand side of this x-intercept. Notice how I'm corralling it in. I'm putting a point on the left-hand side and a point on the right-hand side, and then my calculator is going to guess the x-intercept between those two corrals, so to speak. Okay, so if I want to be on the right-hand side, I want to move this guy down below the x-axis, but I don't want to cross this dip. I don't want to cross the very bottom, the vertex, or my calculator will get confused. So if you hit enter, now it's going to ask me to guess. I don't want to ever guess, so just hit enter again. Now you can see that it says your 0 is x equals -2. So you know one of your solutions, one of your zeros, one of your x-intercepts is -2. Now I have to do it again because remember I had another one right over here. So I'm going to go back to second trace. Remember, I'm going to 0. This time I want to be on the left-hand side of this guy. So I want to be on the left-hand side of this point. That means I'm down below it this time. But I've got to be past that vertex. I try to get as close to the x-axis as possible. So I'm on the left-hand side. Now I want to be on the right-hand side because it's asking for right bound because I hit enter. I hit enter again. Now it's saying guess. I never want to guess, so I'm going to hit enter. And now it's saying x equals 3. So my other solution, my other 0, my other x-intercept is 3. And there's my answer. Okay? All right, let's try this again. Let's take a look at number 83. Number 83 gives me 83, sorry. 83 gives me y equals x squared minus 4. Now I'm going to use my calculator, but I'm going to show it a little different way, just in case you're confused with the left bound, right bound. So remember, the first thing we did is we put it into our y equals. So we went to y equals, we're going to clear our other equation out, and we're going to hit x squared minus 4. Okay, then remember to find the zeros, we went to second trace 0. You're going to have to give it some time to graph. Okay, and I'm going to just kind of sketch this to the side here. Whoops, kind of messy. So I have something that looks like this, correct? And the calculator's saying left bound. Well, remember, I have two x-intercepts right here and right here. I'm going to start with him because I have to do two separate. What I think of this as is I think wherever that x-intercept is, just think of that as a dotted line right through the middle. Okay? Now, if you were to pick the left side of that dotted line, is the graph going above or below? It would be right here. So that means my cursor needs to be anywhere above that x-axis in that curved up branch. Okay, hit enter. Now if I look back at this dotted line, remember I can't go past my vertex, but if I go back at this dotted line, it's asking for right bound. So what's the right side of this? Well, it's anything over here. So now I'm going to move my cursor down below the x-axis and hit enter. I don't want to guess, so hit enter again, and it's saying x equals -2. There's my first solution. Now I'm going to do it again, second trace 0, because now remember I need to do this guy. So over here on my graph, I'm going to think of this as, here's my boundary line. It's asking for left bound, so I want to be right here. I want to be on the left side of that dotted line, but I cannot cross the very bottom. So I'm going to take my cursor, and I'm going to get him over here until I'm on the left-hand side and hit enter. Now it's asking for right bound. So if I look over here at my boundary line, I need to be on the right-hand side. So I'm going to move my cursor over so that I'm up here. Hit enter. It's asking me to guess. I don't want to guess, so I hit enter again. And x equals +2. There's my answer. Okay? All right, so remember, you can't do that on, sorry, I guess I should say, the only time I can use my calculator is if it's asking for finding zeros. So that's on 80 through 88. On the rest of those, 65 through 79, where they have equal signs, I need to be solving using factoring, okay? So that will be like example 5.